Hey math fans, we're on section 1.3.2. Let's get started. So if you remember in the last section, we talked about complex numbers and imaginary numbers. And remember, the complex number has a real component, which is the letter A in this form, and an imaginary component where B is the coefficient for the imaginary component. And if you want to simplify an imaginary number, remember, divide that exponent by 4, and whatever the remainder is, that's what it will simplify to. So if you want to add or subtract two complex numbers, remember there's a real and an imaginary component. And just like the polynomials, you can add and subtract as long as they have the same variable, which in this case is going to be the I or without the I. And then, of course, raised to the same power. Here are some common misconceptions. Example 1 says, is quantity 6 plus 5i plus a quantity of 8 minus 3i wholly real or wholly imaginary? Or does it have a real and an imaginary part? Well, just like the polynomials, as I said, combine like terms. So let's combine the 6 and the 8. You get 14. Well, what about the imaginary? You'll get 5i, and then you have negative 3i, which is going to simplify to 2i. So your final answer is going to be 14 plus 2i. It has a real component of 14 and then an imaginary component of 2i. Example 2. Is 5 plus 6i minus quantity of 5 minus 3i wholly real or wholly imaginary, or does it have both a real and imaginary part? Again, we're going to combine the like terms, but before we do that, since this is a subtraction problem, remember that negative outside the second parentheses there is really a negative 1. You can't see it, but it really is a negative 1. And we need to distribute that negative first. So make sure you do that. So that 5 minus 3i will really become negative 5 plus 3i. And now we can combine like terms. So 5 minus 5 is 0. So it looks like we just lost our real part. So the real part's going to be 0. The imaginary part's going to be 9i. So really this is going to be wholly imaginary. The whole thing's going to be imaginary because we lost the real component. Example 3 is quantity of 12 plus 4i plus quantity of negative 18 minus 4i, real or wholly imaginary, or does it have both? Let's take a look here. First, let's combine the real parts. We get negative 6. Imaginary parts, we get 4i plus negative 4i, and now we have 0i. So it looks like we lost our imaginary parts here. So our final answer here will have basically only a real part, which is just negative 6. Example 4 talks about a circuit in series, and it asks us to combine the total impedance. Now remember, the R value is the real component, and then you have the X, which is your reactance. That's going to be the imaginary component. So if you read the problem, it says element 1 has a resistance of 25, so that'll be the real part, and a reactance of 1 ohm, so that'll be 1I. Element 2 has a resistance of 20 ohms and then a reactance of 1.5. So that means, written as complex numbers, element 1 is going to be 25 plus I. Element 2 will be 20 plus 1.5 I. Of course, the total impedance means we're going to be finding the sum. So let's add those two complex numbers together. So the total impedance will be 25 plus I plus 20 plus 1.5I. Combine the real parts, you're going to get 45. Combine the imaginary parts, you get 2.5I. So your total impedance will be 45 plus 2.5I. And that's going to do it for this section. We'll see you in class.